In this last section, we're going to be using the tool of dimensional analysis to convert between units. In our first example, something we're probably familiar with. When you drive for 4 hours at 55 miles an hour, most people just automatically do 4 times 55 gives you 220. And that's right. 4 times 55 does give you 220. But what happened to the hours? Well, they canceled out. They canceled out because you're doing 4 times 55 divided by 1. So that's 4 times 55 divided by 1. And when you take these hours, multiply it by miles, and divide it by hours, it's not too terribly different than if you do x times y and then divide it by x. When you do x times y divided by x, this simplifies down to just y. It just equals y. And that's because the x's cancel out. The same thing can occur with units. Hours times miles divided by hours, the hours cancel out. And the miles are the only unit left. We're going to look at several examples and focus on the units. Just the units. In this first example, we have carbon dioxide. We want its volume. We have 200 grams of this substance. It always starts off by writing down the given. So I wrote down the given was 200 grams of ethanol. Now I want to come up here and find grams of ethanol in my definitions. And here it is right here. So I'm going to write this definition as a ratio in the next step. But I want to make sure that the ratio is set up so grams cancel out in the next step. The only way to make sure that those grams cancel out is by putting this 44 grams on the bottom. So I have grams times divided by grams. So grams divided by grams would cancel, but the moles don't cancel. I have two other equivalencies. Which of these equivalencies references moles of ethanol, C2H5OH? That's right, here we are right here. 1 mole of C2H5OH is 2 moles of carbon dioxide. So we can set that up as another ratio. Let's go ahead and do that. So I've set that one up as another ratio. So this was moles of C2H5, and then they have to go on the bottom. And see, I took these two numbers and I set them up right here, one on top of the other. But it's really important to always take the units from the previous step and put it on the bottom in the next step. And then lastly, I can convert the moles of CO2 into liters. So I set up my last equivalency as a new ratio. So let's look at this whole setup. Grams are on the bottom. Moles of C2H5 are on the bottom. Moles of CO2 are now on the bottom, and liters are on the top. Every step needs to cancel out the previous step. Grams. Moles of C2H5OH, moles C2H5OH. And then moles of CO2. Only one unit is left behind, and now we can do the math. So here I've got all the numbers. I've got removed all of the units except for the liters, because that's the only one that didn't cancel out. 200 times 1 times 2 times 22.4 divided by 44 times 1 times 1. Well, this part is really just like dividing by 44. So I get 203 liters of CO2 should be produced. It doesn't matter what's going on up here as long as you keep track of your units. I want you to take a moment and try the next two examples. For A, once it's all set up, you should have 245 grams and 1,000 grams on bottom to cancel the previous step, turning it into 1 kilogram, turning it into kilograms, and then use the kilograms to pounds in the next step. And when you do the math, you get 0.54034 pounds. Now let's go ahead and look at the other one. For B, we have 17 grams to start with, so I had to put the grams equivalency of 12 grams on the bottom to cancel out those grams to give me moles, and then I can go from moles to atoms, and the final answer was a big number, 8.73 times 10 to the 23rd. We're going to be using this type of questions in our homework tonight as we go from kilometers to centimeters. And you need to use the chart that's in the front of your notes where it has all of these different equivalencies to practice. Again, your homework tonight is worksheet 1.